All right, number 17, it says, explain in complete sentences, I know you're excited about that, why the following is not factored completely. So let's take a look. So we have our expanded form here, 8x squared minus 72, and then we have the factored form. So first of all, does this even work out? Can you pull out an 8 from both of the original terms? 8 does divide 8, and 8 divides 72, and I could check. 8 times x squared is 8x squared, and 8 times negative 9 is negative 72. So it is factored. But why is it not factored completely? If you remember, you always have to check what's left in the parentheses after you pull out a GCF. If that can still be factored, then you have to continue factoring. The only option here would be taking a look at method number 2, difference of squares, because it has 2 terms. So x squared minus 9. First of all, it is subtraction. X squared is a square because x times x gets me x squared, and 9 is a square because 3 times 3 is 9. So really, our final factored form would be, remember the 8 is still in the front. If I factor x squared minus 9, I open up 2 binomials. You alternate the signs, one's a plus, one's a minus. X squared splits as x times x in the first spots, and 9 splits as 3 and 3. This would be completely factored. So, complete sentences. Let's write out what we came up with. So this is not completely factored. And why was it not completely factored? Because there was another method to factor what was left in the parentheses. So this is not completely factored because I can still factor what was left in the parentheses by difference of squares. So, let's see if this makes sense. This is not completely factored because I can still factor what was left in the parentheses by difference of squares, and that's exactly what we did.